Something changed inside this volcano 10 days ago, and when the thermal cameras caught it, the scientists knew immediately this was not normal. 401 degrees Celsius detected inside the crater on April 2nd, 2026. And the heat was not sitting still. It was spreading, forming a ring, a circular pattern of hotter zones spreading outward around the crater walls. And the official report from the Volcanic Monitoring Agency said those words that change everything. This distribution suggested the development of a fracture system. Spreading around the crater walls. As we speak, I'm going to give you everything in this video, the temperature data, the seismic sequence that built up to this moment, the deformation signals, what the fracture pattern actually means scientifically, and why this volcano sitting in the middle of central Java demands far more attention than it is currently getting from the world. Stay with me because this builds into something important. So, where is this volcano? Slamet is Java's second highest and one of its most active volcanoes. It contains a wide summit area with 4 craters. Volcano Discovery Java, the most densely populated island on Earth. Mount Slamet is an active stratovolcano that summits in the Pemalang Regency of Central Java, Indonesia. Wikipedia, Central Java. Tens of millions of people within potential impact distance of this mountain. Mount Slamet is a location with the coldest average temperature on the island of Java and one of the areas with the highest annual rainfall in Indonesia, namely 8,134 millimeters per year. Wikipedia, 8,134 millimeters of rain annually. That is over 26 feet of rainfall every year. On a stratovolcano, on an island with the highest population density on the planet, and this mountain has been waking up for nearly 2 years. This is not something that happened suddenly on April 2nd. This has been building methodically, step by step, signal by signal. And I want to walk you through the entire sequence because it is the context that makes the current data genuinely alarming. Beginning in May 2024, the seismic network detected an increase in the number of deep volcanic earthquakes, followed by an increase in the number of shallow earthquakes and continuous tremor that persisted through the end of 2024. Smithsonian Institution, May 2024. That is nearly 2 years ago. Deep volcanic earthquakes started increasing. Deep. That means the disturbance was originating far down in the crust, where magma lives, where pressure builds, where the roots of a volcanic system are being disturbed, and then the earthquakes moved shallower, which is exactly what you do not want to see, because shallow seismicity in a volcanic system means whatever is being mobilized below is getting closer to the surface. Seismic activity through March 2026 was dominated by low-frequency earthquakes with fluctuating intensity and continuous tremor, and no significant visual changes were observed. Smithsonian Institution, low-frequency earthquakes. That is important. Low-frequency seismic signals at volcanoes are a signature of fluid movement. They do not sound like the sharp crack of tectonic rock breaking. They are slow, resonant, produced by fluid or gas pulsing through cracks in the rock, and they were continuous, month after month, all through 2025, all through early 2026. While the surface looked quiet, no ash plumes visible, no dramatic visual changes, just that continuous underground humming. The volcano was communicating in a language only the instruments could hear, and then March 22nd, 2026, the earthquakes began to intensify on 22nd March, with signals becoming more distinct and then became more numerous on 27th March. Smithsonian Institution, more distinct, more numerous. In 5 days, the seismic picture went from chronic background rumbling to something sharper, something more urgent. Deformation data indicated magma migration to shallower depths. Smithsonian Institution, magma migration to shallower depths. Let that line sit with you for a moment, because that is not a subtle observation. That is the monitoring network detecting the physical movement of molten rock upward through the crust beneath Slamet. The GPS stations and tilt meters on the flanks of this volcano registered the ground deforming, the volcano inflating, being pushed outward from inside by magma ascending, and then came April the 2nd, the date everything changed visually. Temperature changes in the crater were observed based on a comparison of thermal images. Analysis indicated temperatures of around 247 degrees Celsius on 13th of September 2024, and during that year, the hot areas were localized within the central part of the crater. Smithsonian Institution. 247 degrees Celsius in September 2024, central zone of the crater only contained localized. Temperatures around 401 degrees Celsius were detected on 2nd April 2026, and the distribution of hot areas expanded to include a circular pattern of hotter areas around the crater walls. Smithsonian Institution, 247 to 401 degrees Celsius. That is a temperature increase of 164 degrees in a volcano that had shown no significant surface changes for months. 401 degrees Celsius is 772 degrees Fahrenheit, hot enough to melt lead and zinc, hot enough to cause severe burns in milliseconds, hot enough to ignite most organic materials on contact. But it is not just the temperature number that alarmed scientists, it is the pattern. Can you give this video a like and a hype right now if you are following this closely, because this is exactly the kind of data that deserves to be seen and it costs you nothing. The pattern. The distribution of hot areas expanded to include a circular pattern of hotter areas around the crater walls. This distribution suggested the development of a fracture system, the Watchers. A circular pattern around the crater walls. When heat forms a ring pattern inside a volcanic crater, it is telling you something specific, something that volcanologists have seen at other volcanoes before eruptions. Let me explain this in plain language. In a normal, quiet period for a volcano, the hottest zone is typically the central vent, the main conduit where gas and heat are escaping upward. When heat starts spreading outward in a circular ring around the crater walls, it means the pressurized system below is finding new pathways, new cracks, new fractures radiating outward from the central conduit toward the crater walls, like a pressure cooker whose gasket is starting to fail around the rim. The fractures mean the rock is being broken, being forced open by pressure from below. And in a volcanic system, that pressure is being applied by one thing, the upward movement of hot gas and magma. Now, I want to be precise about what this means right now in terms of official assessment. The alert level remained at 2 on a scale of 1 to 4, and the public was warned to stay 2 kilometers away from the summit. Smithsonian Institution level 2 on a 4-level scale. That is alert. Not the highest level, not an imminent eruption declaration, but it is also not normal background activity. Level 2 at Indonesian volcanoes means there is elevated unrest with a potential for eruption. It means monitoring is intensified. It means exclusion zones are enforced. It means authorities are watching closely. And the day after the 411-degree readings and the fracture pattern emerged, the volcano gave another unmistakable signal. On 3rd of April, white plumes began continuously rising as high as 300 meters above the crater rim. Smithsonian Institution continuously, not intermittently. Not occasional puffs, continuous white plumes, 300 meters above the crater rim. That is nearly 1,000 feet of volcanic gas rising above the summit without stopping. White plumes at volcanoes are primarily water vapor, hydrothermal steam, heated groundwater flashing to steam as it contacts the hot volcanic system below. And when you combine rising temperatures at the crater surface with continuous steam emission and a spreading fracture pattern, you are seeing a system that is more energized than it was even weeks earlier, right? So let me put together the full picture of what we now know. Almost 2 years of increasing deep volcanic seismicity beginning May 2024. Followed by shallower seismicity suggesting the system was migrating upward, continuous low-frequency earthquakes through all of 2025, a seismic intensification starting March 22, 2026, deformation data confirming magma migration to shallower depths by late March. A temperature jump from 247 to 411 degrees Celsius between September 2024 and April 2, 2026, a spreading ring pattern of heat around the crater walls suggesting active fracture development, continuous steam plumes rising 300 meters from April 3rd onward. This is a coherent progression, each signal building on the previous one, each step moving in one direction toward the surface. And the reason this matters beyond Slamet itself is the location, Java. Since 1900, Slamet has had 31 eruptions and has been active during 31 years out of 127. This means Slamet has been in eruption 1 in every 4.1 years on average. Volcano discovery 1 eruption every 4 years on average. This is not a sleeping volcano being awakened for the first time. This is a fundamentally active system that erupts regularly, and its last confirmed eruption was in 2014. That is 12 years ago. The 2014 eruption was characterized by ash plumes up to 4.6 kilometers high, ashfall up to 20 kilometers from the summit, and numerous incandescent lava ejections. Smithsonian Institution ash plumes reaching 4.6 kilometers above the summit. That is 15,000 feet above the crater. Ash falling 20 kilometers away. That is 12 miles in every direction from the mountain, on the most densely populated island on Earth. And before we get to what the historical record shows about what this volcano can do further down in the video, let me give you the deformation story, because this is the part that is not getting enough attention. Deformation data indicated magma migration to shallower depths. That phrase from the official PVMBG report. PVMBG is Indonesia's national volcanology and geological hazard agency. They have been monitoring this volcano for decades. They have seismic networks on the flanks, GPS stations measuring ground movement, tilt meters detecting the inflation and deflation of the edifice. For them to state in an official report that deformation data indicates magma is migrating shallower means their instruments confirmed ground movement. The mountain is physically swelling, being pushed outward and upward by material ascending from depth. In geology, this is called edifice inflation, and in the context of everything else we just described, it is a critical piece of the picture. Think of it like this. You have a balloon. You push air in from the bottom. The walls stretch outward. You can measure that stretching from the outside. That is what GPS and tilt meter stations do. They measure the stretch. And right now at Slamet, the instruments are measuring stretch, inflation, because something is pushing up from below. And on April 2nd, what that something produced at the surface was 411 degrees of heat spreading in a ring around the crater walls, fracturing the rock as it went. Now, I want to go deeper into history because this volcano has surprised people before. The largest eruption of Slamet Volcano in historic times occurred in 2014. It ranks as a Strombolian to Vulcanian eruption with a magnitude 2 on the Volcanic Explosivity Index scale. Volcano discovery. The 2014 eruption was VEI2, moderate, but the activity in 2014 escalated quickly. During September, one active period was 9 to 11 September, when brownish steam plumes rose to 1,500 meters and incandescent lava ejections were observed up to 600 meters above the summit more than 200 times. Smithsonian Institution, 200 incandescent lava ejections in one 3-day period. Molten rock hurled 600 meters above the summit 200 times, and ash deposits were reported 20 kilometers away. You would not want to be living 15 kilometers from this crater when that happens. And there are villages, farms, people within that radius. The 1988 eruption sent ashfall 85 kilometers from the summit, 85 kilometers. That is over 50 miles. Volcanic ash traveling that far does not just inconvenience people. It damages crops. It clogs water sources. It contaminates irrigation systems. It grounds aircraft. It collapses roofs on the most densely populated island on Earth. And Java's volcanic history includes something even more important to understand: the combination of volcanic eruption with the rainfall this island receives. Slamet is one of the areas with the highest annual rainfall in Indonesia, namely 8,134 millimeters per year. Wikipedia, 8,134 millimeters of rain. Now think about what happens when you add that rainfall to a volcanic eruption. Hot ash deposits on the flanks, saturated by intense tropical rainfall. That mixture does not stay on the mountain. It flows as volcanic mud flows called lahars. Lahars are not just mudslides. They are concrete consistency flows of volcanic debris mixed with water moving at speeds of 60 to 80 kilometers per hour down river valleys. They fill valleys. They bury villages. They arrive with almost no warning at the communities downstream, and the Gucci Valley on the western flank of Slamet has been identified in scientific literature as particularly exposed. With a direct topographic connection from the active crater to populated valleys below, what should we watch next? The PVMBG is monitoring every signal from this volcano in real time. The key escalation indicators would be an increase in the intensity of the continuous low-frequency seismicity, any detection of harmonic tremor which would indicate sustained fluid movement through conduits, a further rise in crater temperatures beyond the current 411 degrees, any visual change in the character of the plumes from white steam to gray or brown, which would indicate ash or solid volcanic material being carried upward. A rise in the alert level from 2 to 3. Level 3 in Indonesia's volcanic alert system means eruption is considered imminent or has begun. And a downward extension of the exclusion zone from 2 kilometers to something larger. Right now, the data shows a volcano that crossed a significant threshold on April 2nd, 2026, a temperature that doubled from the last comparable measurement, a fracture pattern that the official report describes as a developing system, continuous steam emission beginning the following day, and 2 years of escalating seismic and deformation signals underlying all of it. This is not panic. This is pattern recognition. I have gone through enough volcanic sequences to know that not every unrest episode leads to an eruption. Some volcanoes inflate and deflate without surface eruption for years, but the combination of signals here is coherent. It points in one direction, and Slamet has a documented history of escalating from this kind of unrest to actual explosive activity relatively quickly. The 1988 eruption sent material 85 kilometers. The 2014 eruption went from intensification to explosive lava ejections in a matter of weeks, and the current unrest has been building for nearly 2 years before producing this thermal signature. That is a long preparation time, which in volcanology often means the system is more pressurized when it finally releases. I will stay on this. Every PVMBG bulletin, every deformation update, every change in the plume character. If this escalates, I will be here. If you found this valuable, share it with someone who should know what is happening under one of the most dangerous volcanic systems in the most densely populated island on Earth. The end screen has more on what else is stirring across the Indonesian volcanic arc right now. Watch it. There is more to this picture than just one mountain. Thank you so much. Stay safe, guys. Be aware. Bye-bye.